Alright, let's talk about the pick index in a mountain array. So this is an array, and then you have to fulfill the mountain constraint, be honest. And you are given an integer array that is guaranteed to be a mountain, and return I such that this constraint, right? So in this case, you are going to return 1. This is because this is a mountain, and this is index 1. This is also index 1. This is index 1. So in this case, this is pretty simple. So I'm going to just draw a diagram. So you will definitely get an array, right? And this array will represent a mountain. So it could be like this, or you can be like this, or you can be like this, right? So in this case, I'm going to find a peak only. So I can actually use the binary search. So for every single time I cut into half, so I will say, in this case, I'm going to cut my entire array to the middle to check. I'm cut into the middle to check if this one is increasing or decreasing. If this is increasing, I'm going to just still deciding this still increment my index, and then I'm going to decide if this the middle one is still increasing or not, and somehow at a point, which is right here, right? I know this is decreasing, right? So I will need to go backward a little bit. So I will just decide like whether or not like in these two index or not, right? So this is binary search. So I'm going to just use low and high. So low equal to 0, high equal to array length -1, and then while low is less than high. So if while low is not less than high, I will know like low and high is actually cross over each other. So in this case, so if this is low, this is high, I will just keep cutting to the half and then find out which one is the middle, and the low will just decreasing, the high will increasing. At some point, the high will become here and low will become here, or they equal, right? If they are equal, I don't have to compare, right? Because they are at a peak, right? Doesn't matter how you design, but this is my solution. So, and I have a mid, and then it's going to be low plus high minus low divided by 2. So you want to avoid all of them, and this is the most easy way to avoid all of them, right? So I'm going to just check if array admit. If this is less than array admit plus 1, I will do something. So this is what still increasing. So I know I need to shift my low to admit plus 1 because the current position is still increasing, right? So I don't have to care about it, right? And then if not, then I can just change my high, right, to mid. Okay, so you might wondering like why not mid -1, right? Because I want to return for the low. The low always keep low will always tell me if this is increasing or equal to the peak, right? And based on this if statement, I know this is increasing for sure. The slope is increasing because array and mid is less than array and mid plus 1. For the else, it could be equal, it could be greater, right? But I don't know which one it is, right? So for the solution, I will just return low just in case, right? Let me run the code, and yes, this is pretty much it, right? And here we go. So let's talk about time and space. For the space, it's going to be constant, all of 1. For the time, you are cut every time half, right? So for every single time you cut into the half is log n, right? So this is actually log n, right? The time. So this is pretty much a solution. So here's my quick note for the time and space. So time is going to be log n, space is going to be constant, and then n represent the length of the array. And this is the solution, and I will see you next time. Bye.